The 2005 version of the Code Handbook on CD had several significant flaws that made it problematic for users. One major issue was the copy protection system employed. This system was difficult to remove and caused compatibility problems with some computers, hindering access to the handbook's content. Another problem was the presence of missing files in the CD. This meant that the handbook was incomplete and unusable on some computers, preventing users from accessing all the necessary information. There were errors within the handbook itself. Some of these errors could have led to incorrect wiring practices, posing a safety risk. Due to these flaws, the 2005 version of the Code Handbook on CD was considered unusable by many. The 2017 version of the Code Handbook on CD was created to address these problems. The copy protection was removed entirely. The issue of missing files was resolved, with all files now included in the CD. The errors present in the 2005 version were also corrected, ensuring the accuracy of the information provided. The 2017 version of the Code Handbook on CD is now considered safe to purchase and is a valuable resource for anyone working with electrical codes. When choosing a code handbook, especially in digital format, it's crucial to consider the reliability and accuracy of the information it contains. Firstly, confirm that the version you're purchasing is the most up-to-date and incorporates all necessary updates and corrections. Secondly, check for any known issues or flaws in the specific version you're considering, such as those found in the 2005 edition. Thirdly, ensure that the digital format is compatible with your computer and that there are no copy protection measures that could hinder access to the content. Additionally, it is very important to understand the structure of the National Electrical Code, or NEC, as this is usually what the handbook refers to. The NEC is organized into chapters, articles, and sections. Chapters provide a broad categorization of topics. For example, Chapter 1 covers general requirements. Articles delve deeper into specific subjects within a chapter. For example, Article 90 covers Introduction to the NEC. Sections provide the most detailed information on a particular aspect of the code. For example, Section 210.52 covers receptacle outlet placement in dwelling units. When using the Code Handbook, you should familiarize yourself with the table of contents and the index. The table of contents provides a hierarchical overview of the code structure. The index allows you to quickly locate specific information based on keywords. When referencing specific sections of the NEC, be precise in your citations. For instance, if you are referring to the requirements for grounding electrode conductors, cite section 250.66 accurately. The NEC contains numerous tables that provide essential data such as conductor ampacity, conduit fill, and equipment grounding conductor sizes. Learn how to use these tables effectively. For example, Table 310.16 provides ampacity ratings for various conductors based on insulation type and temperature rating. Understanding correction and adjustment factors is crucial for accurate ampacity calculations. Correction factors account for ambient temperature, while adjustment factors account for the number of current carrying conductors in a raceway. Always apply these factors when necessary to ensure conductor ampacity is not exceeded. The NEC includes requirements for overcurrent protection, such as circuit breakers and fuses. Understand how to select the appropriate overcurrent protection device for a given circuit, considering conductor ampacity and equipment ratings. Article 240 covers overcurrent protection. Grounding and bonding are critical for electrical safety. The NEC specifies requirements for grounding electrodes, equipment grounding conductors, and bonding jumpers. Follow these requirements carefully to minimize the risk of electrical shock and fire. Article 250 covers grounding and bonding. The NEC addresses wiring methods for various applications, including conduit, cable, and surface raceways. Choose the appropriate wiring method for the specific environment and application, considering factors such as mechanical protection, corrosion resistance, and fire resistance. Chapter 3 covers wiring methods and materials. The NEC provides requirements for equipment installation, including panel boards, transformers, and generators. Ensure that equipment is installed according to the manufacturer's instructions and the NEC requirements. Chapter 4 covers equipment for general use. Special occupancies, such as healthcare facilities, hazardous locations, and swimming pools, have unique electrical requirements. Familiarize yourself with the specific requirements for these occupancies to ensure safety and compliance. Chapter 5 covers special occupancies. The NEC is updated every 3 years. Stay current with the latest edition of the NEC to ensure your work complies with the most recent safety standards. Many jurisdictions adopt the NEC with amendments. Be aware of any local amendments to the NEC that may be in effect in your area. There are many resources available to help you understand and apply the NEC, including training courses, seminars, and online forums. Take advantage of these resources to enhance your knowledge and skills. The National Fire Protection Association, or NFPA, offers a variety of resources related to the NEC, including the NEC itself, handbooks, and training materials. Many electrical equipment manufacturers provide technical information and support to help you comply with the NEC. Consult with qualified electrical inspectors and engineers when you have questions or need assistance with NEC compliance. Electrical safety is paramount. Always follow safe work practices and use appropriate personal protective equipment when working with electricity. Before working on any electrical equipment, always de-energize the circuit and verify that it is de-energized using a voltage tester. Never work on live electrical equipment unless absolutely necessary, and then only with appropriate training and precautions. Always use properly insulated tools when working with electricity. Inspect tools regularly for damage and replace them if necessary. Wear appropriate personal protective equipment such as safety glasses, gloves, and arc-rated clothing when working with electricity. Be aware of the potential hazards of electricity such as shock, arc flash, and arc blast. Follow safe work practices to minimize the risk of injury. If you are not qualified to work with electricity, do not attempt to do so. Seek the assistance of a qualified electrician. Electrical codes and standards are constantly evolving. Staying up to date with the latest changes is essential for ensuring electrical safety and compliance. Regularly review the latest edition of the NEC and any applicable local amendments. Attend training courses and seminars to learn about new technologies and code requirements. Subscribe to industry publications and online resources to stay informed about changes in the electrical industry. The NEC includes requirements for conductor identification. Understand how to identify conductors based on their color coding and markings. For example, grounded conductors are typically white or gray, and equipment grounding conductors are typically green or bare. The NEC specifies requirements for box fill. Ensure that electrical boxes are not overfilled with conductors and devices. Overfilling boxes can lead to overheating and other problems. The NEC includes requirements for cable and conductor support. Support cables and conductors properly to prevent damage and ensure that they are not subjected to excessive strain. The NEC specifies requirements for the installation of luminaires, also known as light fixtures. Install luminaires according to the manufacturer's instructions and the NEC requirements. The NEC includes requirements for the installation of appliances, such as ranges, dryers, and water heaters. Install appliances according to the manufacturer's instructions and the NEC requirements. The NEC specifies requirements for the installation of electric motors. Install electric motors according to the manufacturer's instructions and the NEC requirements. The NEC includes requirements for the installation of generators. Install generators according to the manufacturer's instructions and the NEC requirements. The NEC specifies requirements for the installation of transformers. Install transformers according to the manufacturer's instructions and the NEC requirements. The NEC includes requirements for the installation of panel boards and switchboards. Install panel boards and switchboards according to the manufacturer's instructions and the NEC requirements. The NEC specifies requirements for the installation of surge protective devices, or SPDs. Install SPD to protect sensitive electronic equipment from voltage surges. The NEC includes requirements for the installation of uninterruptible power supplies, or UPSs. Install UPS to provide backup power in the event of a power outage. The NEC specifies requirements for the installation of renewable energy systems such as solar photovoltaic, or PV, systems. Install renewable energy systems according to the NEC requirements and any applicable local codes. The NEC includes requirements for the installation of electric vehicle, or EV, charging station. Install EV charging stations according to the NEC requirements and any applicable local codes. The NEC specifies requirements for the installation of fire alarm systems. Install fire alarm systems according to the NEC requirements and any applicable local codes. The NEC includes requirements for the installation of communication systems such as telephone and data networks. Install communication systems according to the NEC requirements and any applicable local codes. The NEC specifies requirements for the installation of low-voltage systems such as security systems and landscape lighting. Install low-voltage systems according to the NEC requirements and any applicable local codes. The NEC includes requirements for the installation of temporary wiring. Use temporary wiring only for temporary installations and remove it promptly when the installation is no longer needed. The NEC specifies requirements for the demolition of electrical systems. To energize and remove electrical systems safely and according to the NEC requirements. The NEC includes requirements for the inspection of electrical installations. Ensure that electrical installations are inspected by a qualified electrical inspector to verify compliance with the NEC. The NEC specifies requirements for the permitting of electrical installations. Obtain the necessary permits before beginning any electrical work. The NEC includes requirements for the documentation of electrical installations. Maintain accurate records of electrical installations, including wiring diagrams and equipment specifications. The NEC specifies requirements for the training of electrical workers. Ensure that electrical workers are properly trained and qualified to perform the work they are assigned. The NEC includes requirements for the use of personal protective equipment, or PPE. Use appropriate PPE when working with electricity to protect yourself from injury. The NEC specifies requirements for the safe handling of electrical equipment. Handle electrical equipment carefully to avoid damage and injury. The NEC includes requirements for the safe storage of electrical materials. Store electrical materials in a safe and organized manner to prevent accidents. The NEC specifies requirements for the disposal of electrical waste. Dispose of electrical waste properly to protect the environment. The NEC includes requirements for the investigation of electrical accidents. Investigate electrical accidents thoroughly to determine the cause and prevent future occurrences. The NEC specifies requirements for the reporting of electrical accidents. Report electrical accidents to the appropriate authorities. The NEC includes requirements for the development of electrical safety programs. Develop and implement electrical safety programs to promote a safe work environment. The NEC specifies requirements for the auditing of electrical safety programs. Audit electrical safety programs regularly to ensure their effectiveness. The NEC includes requirements for the continuous improvement of electrical safety. Continuously improve electrical safety practices to minimize the risk of accidents. Understanding voltage drop is also important for correctly sizing conductors. Voltage drop occurs when electricity flows through a wire. The longer the wire and the higher the current, the greater the voltage drop. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC provides guidelines for limiting voltage drop in branch circuits and feeders. In general, voltage drop should not exceed 3% in branch circuits or 5% in feeders. To calculate voltage drop, you can use the following formula: voltage drop equals current times resistance, where current is the current flowing through the conductor in amps and resistance is the resistance of the conductor in ohms. The resistance of a conductor depends on its material, length, and cross-sectional area. The NEC provides tables that list the resistance of different conductors. After you have calculated the voltage drop, compare it to the allowable voltage drop limits. If the voltage drop exceeds the limits, you will need to increase the size of the conductor. In addition to voltage drop, you must also consider ampacity when sizing conductors. Ampacity is the maximum current that a conductor can carry safely without overheating. The NEC provides tables that list the ampacity of different conductors based on their insulation type and temperature rating. When selecting a conductor size, you must ensure that the ampacity of the conductor is greater than or equal to the load current. You must also consider any applicable correction or adjustment factors. Correction factors are used to account for ambient temperature. Adjustment factors are used to account for the number of current carrying conductors in a raceway or cable. Always select a conductor size that is large enough to handle the load current and any applicable correction or adjustment factors.